Hello everyone. The question is a sphere of mass 1 kg. A sphere of mass 1 kg. This is the sphere and radius r equals to 1 meter. Rolls without slipping. Rolls without slipping on a fixed inclined plane with an angle of inclination theta equal to 30 degree from the horizontal. Theta equal to 30 degree from the horizontal. Two forces of magnitude 1 Newton, each parallel to the inclined acts on the sphere. Two forces are acted which are F and F. Let us suppose the value of F equal to 1 Newton, another value of F equal to 1 Newton, which are parallel to the incline, are in opposite direction at a distance 0.5 meter from the center of the sphere, that taken distance small r equal to 0.5 meter, small r equals to 0.5 meter, and capital R the radius of the sphere, which is the solid sphere, is equals to 1 meter. Sphere means solid sphere. Moment of inertia of solid sphere, which will be equals to 2 by 5 mr square. Moment of inertia of hollow sphere, which will be equal to 2 by 3 mr square. And as shown in figure, the acceleration of sphere down the plane is acceleration. We have to need the acceleration of sphere down the plane. Acceleration of sphere down the plane. This sphere goes down the plane, and the value of gravitational acceleration equals to 10 meter per second square. Okay, this question is belongs to advanced 2022. Okay, we have to find the acceleration of solid sphere. We know that there are in this sphere whose forces will be acted. Mass is m, then weight is mg, which is vertically downward. Okay, if this is angle theta, then implies that we are taking the two components which are parallel to the incline and perpendicular to the incline. This is the parallel to the incline and this is the perpendicular to the incline. If this angle is theta, then that angle must be a theta, because the angle between two perpendicular lines is equals to the angle between that two perpendicular line, which must be equal. This is the line, then perpendicular of this line, which will be vertical, and this is the inclined line, the perpendicular to the inclined line, which is the perpendicular to the this line. Implies that if this is an angle theta, then that angle must be a theta. This is the mg, then this is the mg cos of a theta, then that value which will be equals to the mg into cos of theta, that value which will be the mg into sine of theta, mg cos theta, mg sin theta, this is the mg. Okay, and another point here, we know that this is the contact point. Let us suppose this is the contact point, this is the center O, this is the center of a mass, this is the sphere. Imply that we can say on this sphere there are the mg sin theta, which is the down the inclined. This is the mg sin theta. We are trying to find out the frictional force. Then find the direction of frictional force. If we find the direction of frictional force, then tendency of that contact, which is the direction of tendency, direction of tendency is the opposite to the frictional force. Then we have to know that this is the mg sin theta is vertically downward, so this is the mg sin theta. Then this contact point is trying to downward, so imply that we can say the frictional force on this point, which will be the f of r, which is the parallel to the incline and up the incline, not down the incline. This is the frictional force. If any disc, any ring, or any solid sphere or any hollow sphere is down the incline, then direction of frictional force is always always parallel to the incline and up the incline, parallel to the incline and up the incline. If any sphere, any ring or any disk which is the up the incline, then also direction of frictional force will the up the parallel to the incline, and direction will be the up the, then direction of frictional force will be always up. If a sphere or ring or disk which is downward or upward. Okay, so direction of frictional force which will be the upward, implies that we can say. Now trying to find out the torque with respect to P point. We are trying to find out the torque with respect to P point. Then what will be the happened? Taking torque, taking find torque with respect to P point. Torque balance with respect to P point. Okay. Look here, at P point there is the mg cos theta. This is the parallel to the mg cos theta, and this is the fr. Then mg cos theta and fr cannot be affected because these two forces will be the passes through the P point. Okay, so we have the affected force will be the mg sin theta, because this force cannot be passes through the P point, and capital F, because this force cannot be passes through the P point, and capital F, and this force cannot be passes through the P point. Imply that we can say, then we are taking the down the incline will be positive and up the incline will be negative. Okay, or we can say with respect to this point, clockwise will be the positive and anti-clock will be the negative, because we are discussing about the torque. Then with respect to P point, mg sin theta is this, then that distance will be the capital R. Okay, so imply that we can say mg into sine of a theta and into capital R, we are taking clockwise direction, because this is the point, this is the mg sin theta, this is the clockwise direction. Also this is the capital F equal to 1 Newton, and this distance will be the capital R minus small r, which will be the clockwise direction. This is the capital R, this is the small r, then that distance equal to capital R minus small r, which will be equals to 0.5, because then that distance equals to, this is the plus and F into capital R minus small r, another point. This is the capital F. Capital F will be the this effect will be the anti-clockwise, because this is the point, this is the anti-clockwise. This is the capital R, this is the small r. Total distance which will be equal to capital R plus small r, implies that this is the minus F into capital R plus small r equals to moment of inertia of sphere with respect to P point into, that is the alpha, this is the rotation alpha, Okay, then that sphere will be the rolling without slipping, so frictional force will be the upward. Imply that we can say, here we are putting the values m, theta, r, f. The value of m equal to 1 kg, and value of g equal to 10 meter per second square, 10, and sine of 30 degree, sine 30 equal to 1 by 2. That value equal to 1 by 2, or into 1 plus f into that number, f is the 1, then capital R is the 1, minus 0.5 minus 1 into 1 plus 0.5 equals to IP. IP means moment of inertia with respect to P point, which will be equals to, by using the parallel axis theorem. Parallel axis theorem means IP equals to ICM plus MD square. IP equals to ICM plus MD square. This is the IP equals to ICM plus M into D square. Imply that we can say, if this is the any body which is moment of inertia with respect to CM is this, if we require the moment of inertia with respect to point P, then that distance is equals to D. So this is the parallel axis theorem. Moment of inertia with respect to P point equal to moment of inertia of that body with respect to center of mass plus mass of that body into distance between that two lines, which must be a parallel. Then Ip equal to ICM plus md square. Then Ip equal to ICM plus md square. Then what value will be the Ip? Ip equals to, Ip means this is the sphere, then moment of inertia of a sphere equals to 2 by 5 mr square and md square. Distance d will be what? This is the P point, this is the O point, this is the CM, this is the required point. So this distance is equals to capital R. Then capital R squaring into alpha implies that m is the 1, r is the 1, then 1 into 1 square equals to 1. Similarly, we can say this is the arrange will be the 7 by 5 into alpha, 7 by 5 into alpha. So we are trying to find out the value of alpha. Now calculate this. 2 2 5 ja 10. This is the 5 number, this is the 0.5, then 5.5. This value is a 5.5 minus this is the 1.5 equal to 7 by 5 into alpha. And what will be value? This is the 0 point. This value will be the 4 because 5 cancel. 5 minus 1 equals to 4. Imply that 5 4 ja 20. This is the value of alpha, which will be equals to 20 divided by 7 equals to, then that number equal to 7 2 ja 14, 7 3 ja 21, 7 2 ja 14, 14 and remaining 6, 7 7 7 ja 7 7 ja 49, 7 आपका स्पेस 7 7 जा आपका 49 and that value will be 60 and 7 8 जा 56. ठीक है, तो 8 जा इस पे 7 8 जा 7 8 जा आपका इस पे 56 and 7 8 जा 56, that the remaining 4 4 8 जा ये 4 42 6.6 approximate 2.86. That value is the approximate 2.86. Division of 20 division of 7 into 20, which value equal to 2.86. This is the radian per meter square. But we are given that condition will be rolls without slipping. Rolls without slipping means ACM equals to R into alpha. ACM equals to R into alpha. Then ACM equals to R into alpha implies that we have to need the value of ACM, center of a mass of sphere, which will be equals to R1 into alpha is the 2.86 meter per second square. This is the final answer, 2.86 meter per second square. This question is the advanced 2022 questions. Basically, we are trying to manage the torque balance. If we will manage the torque balance, then also find out the acceleration of this sphere. If a sphere is given, then we are taking the solid sphere, then moment of inertia of solid sphere equals to 2 by 5 m into r square. Okay.